At the heart of the Kerbol system, we have the Kerbol itself. Also known as the Sun, it's unsurprising that we list it as the first celestial body we've discovered. The Kerbol archives warn that scientists have noted a particular burning sensation and potential loss of vision if looking at Kerbol for long periods of time. This is especially important to keep in mind considering the effect the shiny objects have on the average Kerbol. As you can see, we don't really know all that much about our sun, since the practical applications for it are limited to charging batteries with solar panels. However, recent solar probes managed to get close enough for us to detect that Kerbol is actually rotating. To be fair, this was predicted a long time ago, as all celestial objects rotate, but the interesting part is that its rotation period is exactly 20 Kerbin days. This precise ratio initially got the researchers accused of fraud, but as more observations were made, the evidence became impenetrable. Some Kerbols believe we might actually live in a simulation. Closest to the sun, Moho was always thought to be a fiery place with oceans of flowing lava, but unfortunately the Kerbal mythology was way too optimistic, as the actual planet is much less interesting. Scientists speculate about possible ways to make it awesome like in the stories, and some of those ideas have led to new breakthroughs in aerospace technology. But for now, the surface is mostly gray plateaus with crystallized structures sticking out of them. There's no atmosphere, but intense solar radiation knocks electrons off of dust, which is then lifted up by electrostatic forces to form loose clouds over the entire sunlit part of the planet. Speaking of radiation, Moho has a rather unstable inner radiation belt, as well as a very elongated magnetopause, indicating a weak core. Notice how there is almost no small craters. This indicates that the rock has been formed fairly recently, suggesting recent volcanic activity. So who knows, maybe our ancestors were right about the lava. Lucky for us, there are still small patches of it near the North Pole. Speaking of the North Pole, recent expeditions there revealed an abnormal hole in the ground named Moho. Reports indicate extremely smooth walls that could not have been formed naturally. By the way, this video has been sponsored by the Kerbal Space Center's Human Resources, who are looking for a brave adventurer to attempt a descent into the Moho. They assured that while Moho is very hot, the spacesuits make it tolerable. Ah yes, Eve, the sadistic sister of Kerbin. Being 2.3 times heavier, Eve has 70% higher gravity at surface level. This makes trips to Eve very expensive due to just how much fuel has to be carried. Now Eve does have an atmosphere, and that means aerobraking is on the menu. However, one does not simply aerobrake into Eve's orbit, for you see, the atmosphere there is thick as It is 5 times the pressure of Kerbin, and because atmospheric pressure changes exponentially with altitude, there's this thing called the Eve effect. Let's say you're coming in from an interplanetary transfer and want to aerobrake into an orbit around Eve. Given the spacecraft's speed and drag characteristics, there's an optimal path to slow down to just the right orbit. However, the margins are razor thin. You go a little bit higher and you fly off back into interplanetary space, and if you go just a little bit lower, this is also true for general re-entry, although to a much lower degree. But let's say you've survived and you descend through thick clouds until you finally see a surface. And what a surprise! Even the 150 degrees Celsius temperature, atmosphere of carbon dioxide gas, and inhospitable pressures and gravity are not a problem for life to overcome. Yes, there is life on Eve, although it's limited to only simple plant life. You can also see weird bubbles floating in the air. Current theory is that they're a product of said plant life, but no one knows for sure. At least there's no radiation on the surface, as Eve has an exceptionally strong magnetic field. As for the terrain itself, it's mostly purple hills, but there's Mountain Olympus a bit south of the equator, towering at 7.5 kilometers in height. Another interesting feature is a large crater left by a huge asteroid a long time ago, which may have wiped out most life on Eve. Notice that the terrain has lots of smaller rocks which become an absolute nuisance when landing. Around half of the planet is covered in oceans of explodium, an explosive substance that thankfully cannot burn without the oxygen that is completely absent on this planet. Because of the thick atmosphere, parachutes work very well and you can use rotary aircraft to move around. Eve has about 90% higher solar flux than Kerbin, so you'll get almost double the electricity from solar panels. Just be aware that nights on Eve are very long and very dark, so ensure you have storage and lights. Once you're ready to leave, you'll find that Eve really wants you to stay. The high pressures make most engines really inefficient, and even the most sleek rockets extremely draggy. Combined with increased gravity and high orbital speeds, you'll find that landing here was easier than taking off. The two most common approaches to handle this are either using propellers to lift the ascent stage to about 20 kilometers before using rocket motors, or driving to Olympus to launch from its peak. I should also mention that Eve has a captured asteroid, Gilly, but we'll examine moons in a separate video. Kerbin, the pale blue dot we call home. It's truly a unique planet with so many different biomes. Grasslands riddled with flowers flow into hills and mountains, shores with yellow sand and palm trees, lakes filled with all kinds of plant life, and vast oceans stretching to the horizon. There's also desert with cacti, there's badlands and they also have cacti. Don't forget about tundra with its snowy hills. And of course the north and south ice shelves. It's truly a perfect place for life to emerge, but even the perfect conditions seem to support only plant life, with Kerbol's being the only exception. We're not sure why that is, but just like Eve, Kerbin has a huge crater left by some very angry rock. Maybe the other animals didn't survive the impact. Or maybe Kerbols are just aliens that came here on the UFO that crashed in the Arctic. Either way, we've clearly been here a hot minute, as evidenced by the Tut-an-Jeb-an temple in the desert. But Kerbols always wanted to reach the stars, and that's why we've started the Kerbal space program. The most complex task was reaching orbit, as it takes about 3,400 meters per second of delta V, which is usually more than halfway to pretty much anywhere. Obviously, the first thing Kerbols did as soon as they've reached orbit was throw something at Mon, as it was teasing them for way too long. And then doing the same with Minmus, though much less angrily, as it only dares to show itself during nighttime. But after that, it was time to move on, and one planet seemed like the perfect destination. Dune is a desolate planet, with deserts covering its entire surface. At first, it might seem inhospitable, but the more you study it, the more you realize that it's the perfect place for a colony. It's the easiest planet to reach from Kerbin, requiring just a kilometer per second of delta V. This means you can create huge expeditions, even with low-level tech. But what would the new colonists sign up for? First of all, Dune has an atmosphere. It's not very thick compared to Kerbin, at just 6.7% at the surface, but it's enough for parachutes and aerobraking to work. And it's also almost purely made of nitrogen, which simplifies pressurizing habitats. Dune is also rich in ore, which allows to get fuel and radiation shielding on the planet itself. Yes, there is radiation on the surface, as Dune barely has a magnetic field, and the thing atmosphere does nothing to the incoming radiation. But it's further from Kerbol, so it's not that bad. This also means that you'll get less electricity from solar panels, and you'll need lots of it for habitat heating, as temperatures on Dune never rise higher than minus 40 degrees Celsius, and could drop down to minus 120 degrees at the poles. When it comes to picking a suitable location for landing, Dune offers many flats around the equator. There are also lots of mountains, but those should be avoided as the atmosphere there is too thin to rely solely on parachutes, so you will have to make a powered descent once close to the surface. But if you want something more exotic, you can set your base near one of the poles, which are covered in permanent ice. And no, it's not water ice, it's carbon dioxide ice. But then you'll miss the Ike eclipses, which are an equator special. In case you miss Kerbin too much, you can always come back. Dune has just a third of Kerbin's gravity, so return trips are as simple as it gets. Just don't forget to bring back those Duna berries.